morning, everybody. Anybody? Say hi to Harold. While we're waiting, morning. All right. So, some of you, I'm jokingly saying this, should be experts and of the little project that I'm going to have you guys do. Hey, Joey, good to see you. Good to hear from you anyways. I can't see you. All right. What we're going to be doing, I've been thinking about how, if and how and when you guys can be doing something at home that kind of reinforces some of the things that we're learning online that we normally would learn at school. And so one of the projects that we normally do at school, and I kind of blew it off. I thought we can't do this. And now I'm rethinking it, and I do think you guys can do this at home. And this is something that you probably can have a little bit of fun with. And I actually want you to get somebody to help you and record. And my lovely assistant is bringing me some supplies. Is what we're talking about today. My dog is not my lovely assistant. What we're talking about today is fluid friction. And we mentioned that in the past. We had an assignment, probably a couple assignments on that, one on Google Classroom and one in the packet. There should be one in the packet too. Anyways, fluid friction, let's remember that fluid friction has to do with things like air resistance, water resistance. So hey Brianna, when we're swimming, my dog's trying to get in here. When we're swimming, let's say we dive into the water or jump into the water off a diving board. We're going at a pretty quick rate when we jump off. When we hit the water actually slows us down. Okay, and that is an example of fluid friction. Now, when you're jumping in the air, there actually is fluid friction that exists between you and the air that's around you. Sometimes we think the word fluid and liquid are interchangeable, and they're not. Liquid is basically like the tea that's in my mug here. A liquid, we know what a liquid is, H2O. Oils are liquids, waters are liquids, rain is a liquid. Hey, Malachi. And so we know what liquids are, and we kind of interchange that word fluid with liquid. And we can't do that because air is actually considered a fluid. Any gas is considered a fluid because of its movement. And so there are differences in resistance in different fluids. Like I said, if you're diving off a diving board, there's definitely a difference between when you're traveling through the air and when you're traveling through the water. I didn't dive. I jumped off of, I think it was a 9-meter board. I felt like I was way up there because I don't like heights that much. 9 meters is what, somewhere between 25 and 30 feet up. And when I jumped off that board, I was just moving really quickly, right? And when I hit that water, my velocity changed pretty quickly when I hit that water, because the resistance was totally different in the water than it was in the air. And then my job was to get back up to the surface so I could breathe and not drown. And it actually hurt hitting the water from jumping from that high up. I see these high divers do it, and I don't know how it doesn't hurt them to do it, but it's pretty amazing what they do. Anyways, so our little mini, I'm going to call this a mini project. And when I say mini, we usually spend a couple days on this, a couple class times on this in school. And so what you're actually going to be doing is you're going to be creating something that is showing fluid resistance. And so your objective is to keep your object in the air as long as possible. Okay, and so this is going to involve you using your cameras on your phone or your tablet, or even camera on a laptop or whatever. And so you're going to actually be sending me pictures of your project. And what I want you to do is record it and then send me your best example of how you do. All right. So what kind of stuff am I talking about? Well, right here, you know, some of you guys are good at doing stuff like this, right? So could it be a paper airplane or an airplane of some sort? Does it have to be made out of paper? No. Here's the rules. It's got to weigh less than 16 ounces. So it's got to weigh less than 1 pound. And your objective is to, with no more than the strength of your arm, get it to fly as long as you possibly can. And so there's a couple things to think about when we're talking about fluid friction and air resistance and what's actually going on. How does surface area play a role in how long or quickly something can actually stay in the air? So one of the ideas is some sort of airplane, okay? Balloons don't count. You can't put helium. You can put air in just your breath in a balloon. Some of you have hot enough breath that it might actually float. Is that possible? If it's really cold outside and you breathe into a balloon, relatively hot air, and it's cold outside, is it possible that it'll have a little bit of buoyancy? Absolutely. So an airplane is one example, right? And so one of the things that you're going to be looking at is what kind of resistance am I getting horizontally, and what kind of resistance and what kind of lift. Because the whole reason an airplane actually takes off is because of its movement. It's moving fast enough that the air that's underneath it actually pushes up on those wings. And so the surface area is important, right? The surface area on an airplane, on its wings, is really important. The assumption is the bigger or heavier the plane, the bigger the wings. Boeing makes rather large aircrafts with 4 engines on it. They have to get enough velocity that there's enough lift. So imagine that there's actually wind pushing up on this. Yeah, when it's moving, the wind is actually pushing up on it, lifting it up, okay? So that's one option, is to do an airplane type project, which I know some of you have experience doing in the classroom. I don't think I'm going to name any names, and airplanes don't bother me that much in the classroom, to be honest with you, except that I'm worried about somebody getting it in the eye. Another example would be some sort of a balloon. The catch is you cannot use any sort of gas. That would be unfair. The only thing you could use is your breath to fill it up. And are you going to get any buoyancy? How heavy is the balloon? Balloons in general are heavier than the air that's around them. And so if I take a balloon and fill it up, what's going to happen to it? Okay, the third, and so I'm going to do that real quick. Or at least try. All right. Okay, so is the air in there hot enough that it's hotter than the air around here that it's going to float? That's how a hot air balloon works, right? It literally has air that's hotter than what's around it. Hot air does what? Hot air rises, cold air settles, right? If the air in here is the same as if the temperature of the air in this balloon from me blowing it up is the same as what's in the room, there's not going to be any variance for it to have any lift, and the weight of the balloon itself is going to keep it from lifting. And so what actually happens? It falls, right? Okay, so if you're going to use some sort of a balloon, remember you cannot use helium or anything like that. It's got to be standard air of some sort. I think 1 year we had somebody that was trying to use tape garbage bags together and use hot air, and it was a cool idea, but it didn't quite work. Hey, Brandon. So idea number one is to build some sort of an airplane. Remember, it can't be more than a pound. It's got to be lightweight. Idea number two would be to build use some sort of a balloon. What's the other idea? Is some sort of a parachute or paraglider. Okay, so could you use something that's light and something that's super light, like tissue paper? This is really small. How could I do this any differently? Excuse me, I could maybe use some tape and tape some tissue together. How do I get it to be like a parachute instead of just going like this and falling? Maybe I could tie some strings to the corners of these and put a tiny little weight on it, or maybe just put something that gives a little weight to the corner so that it would float down. A little bit more, it can have some float to it, okay? Another thing that you can use, if anybody's had any birthdays or parties and keep this sort of stuff, this is the tissue paper that comes in like a birthday present or Christmas present that you get in a bag. This is also something that you could use to make something, and again, crash. If we were standing in the classroom, crash, we could have some fun with this. And the objective is, I want to make something that is staying in the air as long as I possibly can. It's showing that fluid resistance, that fluid friction, and the air resistance, like you do with a paper airplane, some sort of light tissue paper, ta-da, like this. You imagine if you got this to actually be in the shape of a parachute, and kept those corners down, and could you get it to float gently down in a controlled way? How can you find out solutions that'll help you? Number one, experiment, right? Will a balloon work? How can I get the air hot enough for a balloon for it to actually rise? That's going to be the toughest challenge, probably. How can I get, what do I need to make an airplane fly the farthest? Do I need the wings to be bigger so I have more lift? Remember, what keeps a plane in the air is the wind the air that's actually underneath it is pushing up on the wings. That's why it has to be moving at a certain velocity based on its weight before it'll actually lift off into the air. So is this one likely to go very far? It really doesn't have much wing surface. I imagine if I made it considerably wider, it might have a better opportunity to actually fly if I made it with a lot more lift, a lot more surface area, so there would be more lift. Remember, it's only as strong as your arm can throw it, okay? You're going to throw it horizontally, you're going to throw it vertically. This is a project that you probably need 2 people on. And it can be anybody, because somebody needs to be recording it. And how are you going to send something to me? You're going to send a video to me. Short video clip, just 15 seconds, 10 seconds, 20 seconds, 30 seconds, however long it takes for you to get your however long your thing stays afloat, right? 30 seconds, 40 seconds? I don't know. Challenge yourself. So this is something that you're probably going to be doing over and over. One of the things we've done at school is we've gone out in the courtyard there as a group, as a classroom, and everybody gets a chance. We have timers. If you can use some sort of a kitchen timer if you have it, and to keep the time that way. You can use, if you're recording with your phone and you need something to keep the time, then you would start when it hits the ground, stop. Oh, it flew for 18 seconds. Reset. Start again, try it again. Here's the thing. We've had some people that actually did this, and I will say this, they failed miserably. What do I mean by that is when they went to test their project, it like hit the ground in an instant. Did they feel defeated? No, most of the time they kind of laugh at themselves and go, that was a complete failure. And then they said, what can I do differently? How can I do this differently? How can I make changes? We've had, and they were in school, we would work in pairs, but they had ideas and they would adjust their ideas 5, 10, 15 times till they came up with the right formula, and test it and retest it and test it and retest it. Is this actually using the scientific method? It is in a shortened version because we're kind of doing everything in our head, right? But we have a hypothesis that I can build something that's going to stay in the air for an extended period of time. That's really what your hypothesis is. And you come up with a design and you test the design, it fails. What do? You go back up to changing your hypothesis and going, I need to try something different on this. I need to use a bigger piece of paper. I need to make sure that the corners are down so that there's actually, so that it's rounded and so that there's actually an amount of air that's kind of catching in it. What can you do that'll help you guys? Go to YouTube, look at a video of an airplane taking off. Really kind of simple. Take a look at a hot air balloon taking off. Take a look at a video of somebody parachuting, okay? And don't go down a rabbit's hole with that one. When you're doing the parachuting thing, you know, there's round parachutes, there's rectangular parachutes. Take a look at, think about the shapes of those and what they can do to manipulate those. And the military, like if you've ever gone to an air show, they always have the Army, they drop out of the plane and they have those rectangular ones, and they can control those to a point where they can land in, you know, a 10 or 20 foot circle, even if they've dropped out, even if they're dropped out of a plane a quarter mile away. Okay, so they have a lot of control over that, and so that allows them to go faster or even slow it down. Look at those videos and think about what they're doing. It's all about fluid friction. Remember, fluid friction happens in air as well as water. A fluid is basically the concept of something that is not solid, okay? Fluid is not just liquids like water or oil or something like that. Fluids, gases are also fluids, so the air around us is also fluid. And so think about that and think about how adjusting the shape can adjust the speed of how quickly something can fall. Think about how, look at different types of airplanes and how their wings are different. Just do some, this is your research part. If you were doing an experiment, you would be doing background research. This is actually the part where you're going, how can I look into this? How can I make this work? You try something and it fails. You go back up to your hypothesis, adjust your hypothesis, make your change, try it again. You can use notebook paper, you can use balloons, you can get a whole bag of these for $1 at the dollar store. You can get this at the dollar store. If you don't, you try to use whatever you have in your house and make it work. And so there's two parts of this. Number one, send me a message or email. Tell me what you're going to do, what your project's going to be. So you can just message me in Google Classroom. You can private message me in Google Classroom so that the whole class doesn't see it, and just say, hey, I think I'm going to do this. Look at that, Mr. Boston's already got his idea that he's going to do with his grandson. His little grandson's, plastic grocery bags also do work. We all got those sitting in the house, probably an abundance of them. Any sort of plastic, and then I didn't have that handy to think of. Who knows? Maybe even an advertisement. Maybe even some sort of an advertisement might work. And so you guys will have fun. You guys should have fun with this. Maybe it'll even get you out of the house. The living room might not be the best place to do it. I don't know. Please don't play with fire or anything dangerous without supervision. You do not have my permission to do that. Who do I need to warn? Some of you are laughing. Be careful no matter what you're doing. You do not have permission to go up on your roof or anything crazy like that. Remember, it's only as far as how far you can throw something vertically or how far you can throw something up in the air and allow it. There goes Mr. Fosnight. Were you planning on going up on the roof? I love it. That's about it, guys. If you have any ideas, please, or questions, let me know right now. It's 10:30. I know Language Arts is getting ready to broadcast. Yeah, fire and high places, anything dangerous, please don't do it. You have timers on your phone too. You can use that. I will be posting the sheet that goes along with this project. This will count towards a grade, and I don't think I can. I mean, you got to have fun with this. Have fun with this. Don't make it work. You should be able to have fun with this. We always have fun with this every year when we do this, and it doesn't feel like you're doing schoolwork and you're getting a grade for it. So go for it. I'm going to get off here because it is past 10:30, and I miss you guys. And be careful out there. Cover your faces when you go out with a mask of some sort, if you have one, and be safe. Say goodbye to Harold. All right, Joey, take care. Bye, Krabby.